This week's episode is sponsored by Panasonic.
You're listening to the B&H Photography Podcast. For 50 years, B&H has been the professional source for photography, video, audio, and more. For your favorite gear, news, and reviews, visit us at bnh.com or download the B&H app to your iPhone or Android device. Now here's your host, Alan Weitz.
Greetings and welcome to the B&H Photography Podcast. My name is Alan Weitz.
And I'm Jill Waterman.
And our audio engineer, Mike Weinstein, will no doubt be jumping in with a question or two along the way. Where will you be on April 8th, 2024? Not sure? Well, you better start figuring it out fast, because on April 8th, there's going to be a gangbuster total solar eclipse that will temporarily turn broad daylight into an otherworldly spectacle across a wide swath of the U.S., Mexico, and Canada. Making landfall around 11 a.m. Pacific time near Mazatlan, Mexico, the path of the eclipse will travel across all 48 states and eastern Canada before passing on into the North Atlantic from Newfoundland shortly after 5 p.m. local time. But the real show is reserved for people who live within or plan on visiting people who live within the path of totality, which will turn parts of 15 states from Texas to Maine into a profoundly mystical experience. As Pablo Fanque once said, a splendid time is guaranteed for all. Back in 2017, B&H celebrated the total eclipse by participating in a 2-day festival organized by the online community Atlas Obscura and held in eastern Oregon's Snake River Valley in 2024. The party will be expanded from 2 to 4 days, and once again, B&H is partnering with the Atlas Obscura for the 2024 Ecliptic Festival, which will be held alongside the Valley of Vapors Music Festival in Hot Springs, Arkansas, smack in the eclipse's umbra, which we'll explain the meaning of soon. To whet your appetite for this cosmic occurrence and to offer insights about nailing eclipse shots while protecting your camera's delicate center, not to mention your eyesight, we're enlisting the wisdom of Atlas Obscura's astronomer-in-residence, Rebecca Boyle, and Gabriel Biderman from B&H's road marketing team. We'll formally introduce our guests in a sec, but first, we'd like to give a big shout-out to Rob E. Gull, a fan of the show who recently posted a review on Apple Podcasts saying he finds us to be both professional and funny. Thanks so much for the kind words, and also thanks for the 5-star rating. Now, if you want to have your very own shout-out in a future episode, all you need to do is post a comment. We love hearing from our listeners, and for anyone who still hasn't subscribed, regular updates from us are just a click away, and they're totally free, so join us on Apple Podcasts or a platform of your choice. We'd love to, A, have you as part of the family, and B, make you famous. Now back to our guests. As a journalist, Rebecca Boyle has reported from particle accelerators, genetic sequencing labs, bat caves, mountaintops, and inside the retractable domes of some of Earth's largest telescopes. Rebecca, I once reported directly from a Snapple factory. Eat your heart out. Based in Colorado Springs, Colorado, she's a contributing editor at Scientific American, a contributing writer at Quantum Magazine and The Atlantic, a columnist at Atlas Obscura, and a frequent contributor to many other publications. She got her start in a small newsroom, but what really set the course for her career was a trip to space camp back when she was in the 6th grade. Her first book, Our Moon, How Earth's Celestial Companion Transformed the Planet, Guided Evolution, and Made Us Who We Are, is a new history of humanity's relationship with the moon, which Rebecca has not yet visited on assignment. And by the way, it's a great book. We're going to talk a lot about it. Gabriel Biderman is a self-taught travel and fine art photographer who has been exploring night photography for more than 20 years. A key member of the B&H road marketing team, he's also a co-founder of National Parks at Night, a leading source of night photography education and hands-on workshops since 2015. Gabe has taught night photography online with Creative Live B&H and at various trade shows, schools, and institutions since 2008. His work has been exhibited in New York, London, San Francisco, and Hawaii, and he's a co-author of the book Night Photography from Snapshots to Great Shots. And for the record, Gabe has been to the moon, but that's another story from what I understand based on hearsay. Rebecca and Gabe, welcome to our show.
Thanks so much.
Well, thank you. It's good to be here.
Gabe, we're going to park you back there for a little bit. We're going to start with Rebecca.
Yep.
Now, you've done some exhaustive research about the moon in your book. That said, based on your research, what's the most surprising discovery you've made about the moon?
Oh man, it's hard to pick one. I think the most surprising thing to me was how colorful it actually looks if you're up there. A lot of the astronauts described all of these different shades of oranges and browns and tans and even like purples and maybe even greens. And it doesn't look like that when you look at it from Earth, but the rocks themselves actually do have all these different hues, which I found really surprising.
But let me ask you a question, though. Again, reading your book, which is fascinating. And by the way, it's not just space tech and nerdy stuff. There's a lot of very interesting things about how the moon really affected our culture, human beings, and everything in general about this planet that we live on. It's incredibly thorough in its research and the presentation, and a real joy to read.
Thanks.
But from what I understood and interpreted, the astronauts saw all these colors. When they came back in, they realized all the dust on their suits and everything was gray.
Yeah.
And the rocks they brought back were actually gray. So how much of that color that they were seeing was refraction, or possibly either from the sun on the stones themselves, or through the visors that they have, which have their own optical qualities? Any thoughts about that?
It could have been an artifact of their sunshades because they had to have these really dark sunglasses kind of over their helmets to be able to see. But there are a lot of materials on the moon that would reflect certain different colors of light. And even if you look at the moon rocks up close, some of them have a lot of color. Like surprisingly, the whole thing shines brightly like this whitish, grayish object in the sky. But if you get up close and personal, the rocks actually do have a lot of different features and different hues that come out even in the sample lab here now on Earth in NASA's Johnson Space Center. I saw some of the rocks and they don't look like what I expected. I thought they would look kind of monochrome, kind of like dinky little dusty gray things, but they're sparkling and they have this hues of green and little flecks of color all throughout them. And I think if you take a photo, if you take really detailed, layered images of the moon, you can see some of these colors end up coming out. And it's more maybe some browns and like dusky hues. But I don't think it's as simple as that the moon is kind of one color.
Well, good to hear that. Now, in your book, you explain that the Earth and our moon are composed of many of the same materials. I believe feldspar is a very common material that we find both here and there. And that's because the Earth and the moon were created essentially at the same time. Could you give us the background story about this? Because it's an interesting story how our planet and the moon came together or came apart.
Yeah. We didn't actually know anything about how this happened until Apollo. And actually, we still don't totally understand what happened, which I find amazing. Like, it's the moon. Shouldn't we know like how the moon got here? And we're actually not totally sure. In part because it's such a singular thing. There's nothing else like our moon in the whole solar system. It's the only kind of paired system of worlds like this, unless you count Pluto, which isn't really a planet anymore. So that's kind of a different thing. But our moon is very unique, and people had a lot of interesting ways for explaining why it got here. And my favorite old theory is that it was calved like a glacier, calving a iceberg. Somehow it was like shorn away from Earth. And that makes some logical sense just because the Earth is spinning and it was spinning faster back in the past when the moon was closer. So if you kind of unwind the clock, it makes a certain kind of sense that might have happened. But that's pretty clearly not the case now. And the Apollo rocks gave us this new story that there was some really horrific event early in Earth's history where something probably the size of Mars completely obliterated our planet. Like they collided in some gravitationally directed dance, and both planets were totally destroyed. Like there would not be any remnants of it at all. And the result is that this cloud of vaporized rock is swirling around the sun. And within this cloud, two new worlds coalesce and combine, and that's the Earth and the moon. And so they're born from the same stuff at the same time, essentially, which has to be the case if you look at the chemistry of the rocks. So the moon rocks look different from Earth rocks, maybe not in their color, but in their texture and their structure, they're so jagged and blocky and crystalline. They don't look anything like rocks on Earth. But if you get up close through microscopes or with detailed chemistry, they're really, really similar, which is weird because we know, or we think from planetary formation theories, that the way planets form is that they combine in crumbs around young stars. And these crumbs get a little bit bigger and then a little bit bigger, and it sort of snowballs, and they sort of hoover up all the other crumbs around themselves and become big enough to become circular and collapse under their own gravity and become spheres. And when this happens, where they're located kind of drives the process of what they can have in them. So you can look at rocks from Mars, for instance, which we have some meteorites from Mars on Earth, which is kind of crazy to think about. But if you look at them, measure the isotopes, which is like the ratio of certain elements in the rocks, you can tell pretty much right away that a rock is not from Earth if it's from Mars. And that's because of things like the ratio of oxygen is in the rock. So the moon should be the same. Like if the moon is formed from this giant impact from a different planet, then it should look like that planet, whatever that planet was. We call it Theia, which is the mother of the moon in Greek mythology. And it turns out it does not look like Theia. It looks like Earth, which is weird. And that kind of led us to this newer, updated theory of the giant impact, which is that it was so horrific and so total that both planets had to have been completely mixed and kind of reformed from the remains of that terrible thing. And that's why they look chemically pretty much identical.
But physically, they're different because Moon does not have an atmosphere, and we're both constantly being bombarded by all kinds of space junk and rocks and asteroids, and 99% of this stuff burns up in our atmosphere. But on the Moon, it just pummels it, which means that the Moon is essentially like Los Alamos, where they were testing nuclear weapons. The ground itself has a glass-like quality to it, and it's electrically charged, which just sounds like would be a joy to be at the beach there. I can't imagine cleaning that out of my bathing suit. You touched about one thing that was kind of interesting, and I wanted to go back to it, and that is that the Moon and Earth are very unique in our solar system in that the Moon is really large in relationship to Earth. And if you look at the other planets, the moons are tiny little nothings, like nodules drifting around. But here we have this younger sibling, literally and figuratively, that's going around with us. And that not that long ago, before telescope came into being and we had a better understanding of astronomy and physics, a lot of the earlier cultures believed that the moon and the sun were actually the same size. They were just a yin-yang. There was a daylight version and an evening version. These were just two heavenly bodies. They look the same size, they act the same size, and even during the eclipse, they almost perfectly match. You just get a little bit of the sun coming around. You want to elaborate on that a little bit? Because that's just an interesting factoid.
Yeah, this is one of those things that never ceases to amaze me, that the moon and the sun appear to be the same size in the sky. And it's because the sun is 400 times larger than the moon, but also 400 times further away.
Yeah.
And so as far as we can tell, they are the same. And the moon is really big relative to Earth. Like it's 1/4 the width of this planet. And if you think about that in terms of the other planets, like you said, like the moons of Jupiter has like 81 moons. I think they just found another one actually, but they're like crumbs. They're nothing compared to Jupiter. And Earth's moon is huge. I mean, it's just enormous. And it's also really far away actually, which I think is also something people don't necessarily realize when you look at it. You could fit almost 30 Earths between here and the moon. You could fit almost all the other planets between us and the moon if you just line them up side by side.
Is it that far? Really?
It's that far. It's 250,000 miles away. It would take like 6 months if you could drive there, like going, highway speeds, which you can't. You have to go a lot faster than that. But
I don't do highway speeds.
Yeah, it would be faster to go a lot quicker than that. But yeah, it's very far. And I think it's kind of surprising when you think about that. And that's why it looks kind of little in the sky. But it's actually really big compared to this planet and compared to other moons of other planets in this solar system. But yeah, the cosmic coincidence of total eclipses is kind of mind-boggling to me. And it's just right now. Like in the past, the moon was closer, and so it would have blocked even more of the sun, and you wouldn't have really maybe seen the corona the way that we'll be able to see it here coming up in April. And in the future, it will be further away. The moon is moving away from us. So in the distant future, it won't be big enough in the sky to eclipse the sun. So you'll only have these sort of ring of fire eclipses that we had in October of last year, when the moon is a little bit further away in its orbit. But that's far away. Like we'll all be uploaded into AI systems by then, so we don't have to worry about that.
We'd like to schedule to have you back on the show when that happens. Just keep your calendar clear. I'm curious about one thing. You just mentioned that the moon is, in fact, moving further away as it spins around. The distance is increasing. At what point will it become its own planet, for lack of better words? And would it be a planet? Would it be categorized like Pluto as a subplanet, or whatever they term them now?
Oh, that's a good question. I guess it would be. Technically, it could be considered a dwarf planet, which is what Pluto is considered. But once it leaves Earth, I don't know. It wouldn't be a moon anymore. It wouldn't be a satellite.
It would be Mr. Moon.
Yeah, that's right. Yeah, but that's so far into the future that like I don't actually know if that will ever happen in terms of how long it would take for the moon to move so far away that it completely divorces itself from Earth's gravity. I mean, that would be a very long time from now. And it's possible that the Earth itself would have other problems, like the expanding sun or, something else.
So, Rebecca, thinking in a closer time frame, the distance between the Earth and the moon does change regularly during its orbit. And that relates to why there are different types of eclipses.
Yes.
Can you tell us more about that?
Yeah. So we learned in the 1600s from Johannes Kepler that planets and satellites of planets don't orbit in circles. They orbit in ellipses. So we have these nice oval patterns that we trace through the solar system, and all the moons that orbit all the planets do the same thing. Actually, so do satellites. We have to kind of develop these nice little oblong orbital mechanics. And because of that, sometimes the moon is closer to Earth and sometimes further away. And when it's closer, we all heard the phrase supermoon, which is when it does look brighter. It looks like about 14% brighter during a supermoon. And this is when the moon is just on the nearest part of its orbit around Earth and happens to be full. So like a full supermoon is really bright and it's very visible. You can definitely tell that it's a little bit different than a micromoon, which is kind of the opposite. And that's when it's more distant on its orbit around the Earth. And it looks a little bit smaller in the sky. It's a little bit less bright. And importantly, it has a different effect on the tide. And when the moon is closer and it's a supermoon, full moon, you would have a much more powerful king tide. Or when it's further away, you have a weaker tide. So the high and low tides are weaker. But yeah, this is why we have these two types of solar eclipses. So we have coming up is a total solar eclipse. So it's like perfectly aligned. The moon is in just the right spot to block the disk of the sun, where all you'll see is the sun's outer atmosphere, the corona. But in the fall of last year, in October, we had an annular eclipse, which is also called a ring of fire eclipse. And this happens when the moon is a little bit further away on its orbit. So it's like a micromoon, new moon would be the cause of an annular eclipse. And it's not quite big enough in the sky to totally block the sun's disk. So you see this like black hole surrounded by a thin ring of orange fire. And that's what we had in October. But the show in April is the main event, the total solar eclipse.
Cool. So actually, what you were describing about the tides, will there be a king tide together with the upcoming eclipse?
Well, I don't know, actually. I'm not exactly sure where it is in its orbit. It will be a new moon.
Right.
That's just how that has to work. Like new moon meaning like the moon itself is not visible to us because it's so close to the sun. And in this case, it's right in front of the sun. So we won't see the moon until the eclipse happens. And at new moon, we have the highest high tide and lowest low tide because the moon and the sun are aligned with Earth, kind of in a straight line. In a total solar eclipse, a completely straight line called a syzygy, this arrangement of worlds. And it does have a stronger effect on the tide at that time of month, just as a full moon does. But it also has to do with its location relative to Earth. And I have not looked up that number right now. I don't know exactly where the moon is going to be on its orbit during this eclipse, but it will be a new moon. So no matter what, it will be a higher tidal cycle.
Wow.
I would imagine it'd be hard to generalize because it's starting off off the coast of Mexico in the Pacific, and it's ending up in the North Atlantic. So
yeah,
it's a little bit hard to predict all that. You really got to look at the charts to see,
right.
where
Like,
the bodies of water are at that time.
You do need to know the tides. And that is the thing. Researching this book, I learned the tide is so much more complicated than I ever thought. Like, it's all lies, what you've been told about the tide. It is so much more complex and like violent and fundamental than I ever imagined.
Well, I imagine where it starts off in Mexico, it's relatively mild because you're closer to the equator, where it ends up in Newfoundland. And that's where you have like the Bay of Fundy and those 50-foot tides that are nuts. I've seen them. It's just crazy. It's two different worlds.
Yes.
Yeah, but is it not right to think about the moon's gravitational pull sort of sucking at the Earth's oceans and like dragging the high tide towards that part of the Earth and the low tide, on the other side? It's much more complicated than that, but in a fundamental sense, that's what's happening, really?
Sort of. Yeah. I mean, it is pulling on Earth and Earth's pulling on the moon, and this sort of interaction between their gravity is what causes the tide to rise and fall. And it's nice to think about it in the terms of like the moon is dragging on this chunk of the ocean and like switching it around, but it's really the entire Earth itself, the entire ocean is being spun and yanked around. And
there's a lot of different forces working all.
There's a lot of forces. And because Earth is rotating, that also has an effect. That's why we have high and low tides twice a day. So on the side nearest the moon and the side opposite the moon, there's a high tide and a low tide. Yeah, it's a really complicated interaction.
Something that's probably a little bit easier to explain or map out would be the width of the path. In other words, there's going to be a path across the country, and it's going to be gradual. It's going to be really dense in the center and then fade out towards the edges, and then just some people on the very edge may not notice anything happen. What's the width? And again, I know you have topography to deal with here, mountains and valleys, but say across the central plains, where it's relatively flat, how wide is the path of totality, and where does it start getting a little bit fuzzy, and at what point does it just become meh?
So I have to do the math here because I have it in kilometers. The average eclipse path it's about 90 miles, between 90 and 110 miles, it looks like. So there's really like two parts to the path of an eclipse. And one of them is the umbra, which is the sort of inner part of the shadow. This is where the entire sun has been blocked.
Okay.
And it's where you'll see darkness. And the stars will come out. It will look like twilight at best. And it looks like nighttime. This is the real main show of a total solar eclipse. There's also the penumbra, which is kind of the outer edges of this shadow. And that's where the light is only partially blocked. The umbra is actually pretty thin. Like it's a pretty narrow strip of Earth where this takes place, where the shadow of the moon is aligned exactly to block the entire sun. And it's not a very wide path. It's like I said, like maybe 100 miles.
I didn't even think it would be that wide of totality. I thought it
depends on where you
than
are. It has to do with topography.
Gotcha. Right. Understood. Yes.
Does it start larger and get narrower as it progresses?
Yes, that has a lot to do with topography. Like it will appear to be wider or not. But it also has to do with like the node of the moon in the sky. And this gets into like a lot of celestial mechanics.
Oh, we've got all day. Go for it.
Yeah, I've got a Radio Shack calculator here, so I can just punch in those numbers.
But yeah, there are a lot of like numbers that are confusing because where the sun is in the sky in this part of the year in the Northern Hemisphere, it's just after spring equinox. So the sun is a little higher. And the moon, again, is moving too. They both seem to do this like double Dutch phenomenon where like in the spring, they're both kind of in the mid-latitudes of the sky. in the winter, the moon is right overhead and the sun is low on the horizon. In the summer, it's reversed. So the sun is overhead in the summer and the moon is like lower in the sky. So you might be able to see it in your window and it's more obvious in the summertime. And this is also related to where the eclipses happen in the sky. So this one is in April. So we'll be just past the northern hemisphere vernal equinox. So the sun is like nicely in the upper part of the sky, but not right overhead yet. Like if it was midsummer, it'll be easier to see without having to look totally overhead. You'll be able to crane your neck a little bit to look at it. And all these positions have a big effect on how wide the eclipse path looks, how long it lasts. This eclipse is 4 minutes, give or take a few seconds, depending on where you are. And the eclipse in 2017 was only about 2 minutes. And again, that has to do with where the objects are and how Earth is tilted relative to the sun. And all these things play a role.
By the way, are there like eclipse chasers, like tornado twister chasers?
Oh, yes. Yes. They call themselves umbraphiles.
I love
and
it.
they are people who chase eclipses. I have a few friends who actually do this, and they literally travel the Earth in search of this experience of the moon slipping in front of the sun.
So you can drag the 4 minutes out.
They don't actually race the eclipse. I mean, you need a jet to do that.
You do need a jet.
That's what I'm saying. Yeah, you get an F-15.
And there is a flight, actually.
Right.
I believe Delta Airlines.
Yep, Delta is doing it.
Huh.
I'm not sure, but I think United Airlines might have flights that are planned to chase this path. My dad actually is thinking about doing this. My dad is a retired commercial airline pilot and
Oh, wow.
now has his own plane, and he's thinking about trying to map out a flight plan
Ooh.
to stay in the umbra longer. But it would be only like maybe another minute. Even the fastest jet doesn't go as fast as the sun.
Wow. I waxed my car. I'm going to take it up 95.
Really?
I'm going to see how I can do it.
Whatever you need to do to get a good view.
Hey, it's a convertible. Drop the top wax and just listen. Let's see how far we can get with this
Oh,
thing.
there you go.
Now, Manhattan itself, just to be a little bit selfish about that, obviously our listeners are all over the planet. Manhattan itself, from what I see in my notes, we're going to have about a 91.2% totality. That's pretty darn dark.
It's pretty good, but it's not going to be that dark. It'll be weird. The sunlight will look strange, like it's been filtered through like the, Valencia filter on Instagram or something, where like it's kind of metallic. The sky looks a little wrong. You're like, the shadows are kind of weird. You will see one of the best things to see in an eclipse that's not exactly in the umbra is crescents on the ground. So like look through leaves of a tree.
Yes.
And hold your hand up and you'll see crescent suns instead of just regular light like you're used to in the shade. You'll see like dappled crescents everywhere, which is really cool and something to see. But it won't be dark in the same way that it would be during the total solar eclipse in the middle of that umbra, but you'll still see some cool atmospheric effects.
One of the things that always struck me about the eclipse, the several I've gone through, is that the light levels drop off as if the sun is setting, but the light doesn't turn warm in color. It stays the same, neutral blue or whatever. If it's midday or whatever, it doesn't shift to that late afternoon warm gold light.
Yeah.
Okay, it stays neutral, which is kind of weird, and it just dims out. Something I'm kind of curious about, as a journalist with a special attraction to science and astronomy, you spent a lot of time staring at the stars and the planets through a telescope. Do you have any pointers or best practices for handling a telescope setup? Because, again, that's going to be a handy tool to have.
Well, for an eclipse, you would need really special equipment. And I would defer to Gabe on the best setup for trying to view this through a telescope or take photographs. But if you're looking at the night sky, I mean, I have a pretty decent Celestron telescope. And my kind of stargazing habit is to look for some deep sky objects, but I just like looking at star clusters and the moon and kind of some more familiar objects, like some stars within constellations and some of the more famous nebula you can see in constellations. But you would not want to use that sort of setup to look at the eclipse. It would be cool, and this is something I've wanted to do, to have a telescope out to look at dark sky objects during a solar eclipse. But then you would miss the eclipse, which is really the coolest part of it. So I've never done that, but you would be able to see a surprising amount, and it would be fun to see like objects that would be hidden by daylight during the eclipse. If you wanted to point your telescope away from the sun and look at the darker part of the sky, I mean, sometimes the planets are really visible. I think during this eclipse, you should be able to see Mars, and I think Saturn will still be visible, and Venus will be very close to the sun. That would be really fun to look at through a telescope during the eclipse. But again, like then you'd miss this beautiful phenomenon of the total eclipse.
Which
so
I think
I would
is
rather save that.
Yeah, no, true. And it's important to emphasize, you don't need any gear to view an eclipse. It's there. It's
That's right.
like looking up at the sun and the moon. Just don't stare at the sun. Something I do want to touch upon, you mentioned it briefly. We were talking about the optical phenomena, like the dappled leaves, they take on the crescents and all that stuff. One of the things that I did with my kids earlier on, and I still do, is that when an eclipse comes around, view it in a puddle, a lake, or a pot of water, and just look at the reflection, because the reflections do not have the damaging effects on your eyes. Now, I've had somebody tell me otherwise. Now, I've done this several times. I just need reading glasses. Can you clarify this?
So during the total phase, if you're lucky enough to be in that like 100-mile-ish strip of land where the sun is totally blocked, you can just watch. Like you don't need glasses. It's safe to look at the total eclipse. It's safe to look at the corona. You have to be very careful when you see this phenomenon called the diamond ring effect, which is the sun shining behind craters on the moon. And it looks like an engagement ring in the sky because there's this like very faint ring of the corona and then a very bright sparkling light coming through some of the moon's deeper craters. Once that's visible, then you should look away because then the sun's coming out and you don't want to hurt your eyes by looking at that. And then after that, and before the totality event, then you would want eclipse glasses, which are like a special kind of filter that blocks all light except for a couple spectra of the sun. So you can see this kind of orange ball. And if you can get eclipse glasses, get them now because they're going to be a very hot commodity in the next couple of weeks. And that will allow you to see, it looks like someone's taking a bite out of the sun from anywhere you are in Manhattan, in the northern latitudes especially. It'll be really great viewing in southern latitudes at the beginning of the eclipse. If you're in Texas or Oklahoma or Arizona, New Mexico, it would be really great to have those eclipse glasses. And you'll still see this interesting phenomenon, but it won't be safe to look at it without them.
I think also if you are into infrared photography and you have an R72 filter, which is incredibly dense glass, you can just hold it up to the sun, you see a dull yellow ball. You can use those too for viewing. Just make sure that it's like an R72 heavy density.
Yes, and I would be still very careful just looking through it with your eyes.
Yeah, as soon as you start smelling burning flesh, look away. Anyway, also around the same time as the upcoming eclipse, the comet 12P Pons Brook will be orbiting close to the sun, and it's believed the comet will be both visible and photographable in the night sky. Does anybody have any tips on how to visually locate this comet in the night sky using a telescope, or maybe even with the naked eye? Will it be visible just staring?
It should be. It should be very bright, actually. It's going to be a really interesting comet. This will be one of the brightest comets in years. And it's already been shedding material. People with pretty good telescopes now and astronomers are kind of tracking it as it's getting closer to the sun. And it has been sort of emitting some of its icier material. So comets are like ice balls, basically, that are dirty. And as they get closer to the sun, some of their material starts to sublime, to just vaporize and create this tail phenomenon called a coma. And as it gets closer, it gets brighter because it's happening on a stronger scale. So we don't really know exactly yet how bright it's going to be when it gets to the closest point to the sun, which is April 21st, right after the eclipse. So it's very possible, likely, that it will be visible during the eclipse, which is really cool. And I think that will be a pretty special phenomenon that, people in times past would probably have imagined as an omen of something, or something very lucky or very unlucky. Imagine that all of a sudden the sun is gone and it's darkness around you. There's this flaming hole in the sky, and there's a comet near it. Like, it's kind of terrifying.
What can go wrong?
Who knows? Maybe the Cubs will win the World Series again.
There's something positive to think towards.
By the way, Rebecca, does the inverse phenomena happen from the position of the moon? Like, have astronauts ever... I know the annular proportions are different, so the Earth would totally block the sun, but has that happened or been documented by astronauts?
There was no lunar eclipse during any of the Apollo missions, but that would be something. I mean, that's in part because of the timing. They wanted to have, lunar day.
Right.
Like, you don't want to be on the moon during the lunar night,
Right.
because you are going to freeze. And if you're there during lunar day, you need an air conditioner because it's so hot in direct sunlight. But that would happen during a full moon, and a total lunar eclipse is the light of all of the sunsets and all of the sunrises on Earth reflected on the moon as the Earth blocks the sun from the moon. So if you were there, it would be very dark, but also very orange, very red.
Very
and
romantic.
That would look really awesome.
Yeah. Good date night.
cold, but
Cold,
warm.
yeah. And a long date night, because we should say that the day-night cycle on the moon is...
It's 2 weeks.
2 weeks, okay.
Lunar day is 2 weeks, and lunar night is 2 weeks.
Wow.
And that just means that, in a given location, like, it's bright for 2 weeks and it's dark for 2 weeks.
That's a lot of Netflix binging. That's all I'll tell you. All right, we are going to take a short break, and when we come back, more with Rebecca Boyle and Gabe Biderman. Stay tuned.
With the Lumix camera series, Panasonic is dedicated to achieving the highest possible image quality, resulting in compositions that faithfully reflect the photographer's intent. Panasonic strives to enable every photographer and videographer to realize their vision by creating cameras that break new ground in ergonomics, focus, and performance. Panasonic's G-Series and S-Series cameras, popular with both enthusiasts and professionals, strive to be the best camera of choice for all your creative needs. Head on over to bnh.com for more information about Panasonic Lumix cameras, or use the link in our podcast show notes.
Okay, we are back, and we're going to shift focus here onto Gabe. And Gabe, let's talk about photo gear. What's your go-to setup for photographing an eclipse, and how do you decide on what lens or lenses to use? And I'll tag on a third part to the question. Is there such a thing as an ideal focal length to use for capturing eclipse?
Sure. So I think it's become a little status quo to kind of capture the eclipse two ways. Everyone loves a closer look, of course, at the eclipse, and we're going to do that with a telephoto lens. So something in that 100 to 600 range is going to get you very close with photographic lenses. And then, of course, telescopes. You don't need a super powerful. In fact, 1,000 is I wouldn't go much closer than that with a telescope. So everyone wants that close look at the eclipse and the whole transit of the eclipse and all the different phases that we're going to get of it. Those are great, but what separates your shot from all the others, right? And so all those kind of look maybe the same. All of them look the same, right? But I think what's important is to take a wider shot and incorporate where you are experiencing this eclipse. Because bottom line, yes, we all want to photograph it. But even more important than that is to experience it. And so having that shot, that memory of the location that you experienced it, I think is even the more important shot. It's also a little bit the easier, requires less maintenance to capture that shot. But to me, that's going to be your longer lasting memory to do that. Obviously, Rebecca pointed out, when we put these solar filters on, all we can see is the sun. We're blacking out all of the landscape. That's great for the telephoto shot, but that's not good for the wide angle shot. So what we have to do for that is we need to capture the landscape either before the sun comes into transit, into your composition, Or you can take it very briefly. You know, it's not safe to capture the sun, but we all take pictures of the sun, let's be honest. We've all incorporated the sun in many photographs. And for brief moments, it's fine, but we don't want to be without a solar filter taking pictures pointing towards the sun for more than a few moments, I would think. So you could take a picture of it, a wide angle shot especially, and capture the landscape and have that sort of more natural light. Another thing that I don't see many people do, it's something that I'm going to experiment with this time, is when we are taking the wide picture during totality, it's still too dark to really get the landscape. Again, we're kind of exposing for the eclipse, and that still makes the environment that you're in quite dark. But I'm going to try to also capture an overexposed eclipse shot that, again, gets the better shot of that landscape, because we've kind of talked about that metallic, that silvery light that is very unnatural. And again, that's also part of the experience. I've not really seen that captured in a wide angle shot. And that's important to do. I think that during the last annual eclipse, I saw a lot for the first time, a lot of people taking pictures of the sun. They would take the filter off either in the transit, in your composition, at either the beginning or the end. So you'd have a sort of a sunburst at the beginning or the end of the shot. That was kind of creative and new, I thought. And that's another way, again, to do it. So a lot of options for both the wide angle, a lot of considerations. The telephoto shot is going to require much more maintenance, much more tracking. And then running two rigs, it complicates things.
How do you juggle that?
It's a juggle, for sure. It is. But again, I think for that wide angle shot, once you set it up and do whatever you need to do, then you just set it on an intervalometer, right? So typically, the sun will move its own width in about 2 to 3 minutes. Okay, so I can set up my wide angle shot. I can get any foreground shots I want before. Then I put the filter on, and then I just set it up for an interval every 2 to 3 minutes. And then that's it. That kind of leave that be. You know, what's important, I think, for that wide angle shot is that you do your homework prior and when you get to the scene, and just make sure your composition, it incorporates the full transit of the eclipse. That's for this eclipse, an hour and 50 minutes prior and an hour and 50 minutes afterwards, right? So I don't think compositionally, if your eclipse is to the right, you know, and it moves out of frame, you don't have, I think at least most people want that full phase at the beginning and at the end. So make sure you have that balance and room in your composition for that wide angle shot. But it is a juggle. Unless you've got some really sophisticated tracker, your telephoto shot is going to be on either a gimbal, a tracker, a geared head. I would advise anything but a ball head. And I'm a huge ball head fan, but ball head will require the most maintenance. So get out your older, maybe the 3-way heads or a geared head. Gimbals are great. I love gimbals. We often think about these for wildlife, but they're great trackers. And then if you have a tracker already, do not get a tracker now. I'm sorry. To learn it in the month that we've got, don't do it, But
by tracker, do you mean like a computational kind of thing, which it sort of knows where the sun is on that day? And sort of...
Yeah. Like when I shot the 2017 eclipse, we had a workshop, a small group of people, and one of them was this woman who think of it as a computerized ball head that was moving, but it was funny, her computer, she had to have her PC computer rigged in, and again, we're in the middle of nowhere, and so she had to make sure that she had enough juice for that. And it was funny, the computer was also talking. It was saying, okay, moving now, or blah, blah, blah. So that was great. It was telling it, but it did fail a few times, as trackers do. Matt Hill, my good friend and partner at National Parks at Night, for the annular eclipse, had a great experience using the Benro Polaris, which B&H sells. It's a widely, sophisticated
all-in-one tracker
that you will use your app that you program it in, and you point it to a celestial object like the sun or other celestial objects, but you can point it to the sun, and then it will track. And so that's it. You have to make sure you practice and everything else, but there are plenty of other trackers out there. You need to counterbalance them. We had one person, the tracker flipped, and that's going to be something that is really going to be an issue, especially with this eclipse, because we've also mentioned that it's very high in the sky. Right. So that's going to be a challenge for any tracker out there, is that we're going to be pointing almost directly up, especially with those telephoto lenses. So you got to make sure you're counterbalanced, and you're practicing now with the gear you have.
Is there specific things that would be best to practice with?
Track the sun right now.
The sun, yeah.
Track the sun right now. Go out there. I mean, the eclipse is going to happen depending upon where you are, but find out where it's going to be. It's going to be from 10:30 to 2:30 for the most part for most of the North America. So go out there now. I mean, as we get to the equinox and after, it's going to be getting higher to the sky. But hopefully you've got the gear you want to use. That's what I'll say now. Incorporating new gear now is going to require more practice, right? But go out there, the times that it's going to be and the location you want to be, and start experiencing that now. Use your solar filters. Hopefully you've got your solar filters as well on the equipment, and be testing that out now. And to be honest, don't just test it for 10 minutes.
Right.
Test it again for that. We said an hour and 15 minutes before, an hour and 15 minutes after. I'm sorry, this is 2.5 hours worth of homework that we're asking you to do. So bring a stool, bring a comfortable chair,
bring a sandwich, a bottle of water.
Stay hydrated.
Something I'm curious about, we're talking about trackers, and a lot of our listeners do not have trackers. And as you said, if you don't have them right now, it's too late. What would you say, assuming you're working on a tripod, which I think is very highly recommended in this case, I don't care how good your image stabilization is, what would be the shortest shutter speed that one should be using to get a sharp photograph, a perceptually sharp photograph?
Yeah, so that's a great question. We always use a shutter speed rule that you use the same as the focal length, and that's for a handheld, but it serves well on a tripod as well. I will say you'd be surprised. At the 2017 Eclipse, I was bracketing from 2 seconds to a 60th of a second. And I got sharp images.
Oh.
I wasn't on a tracker. I wasn't on anything. I mean, some were blurry. I was also shooting these in burst rate. I was bracketing, right? So within my bracket, I was going 5 to 7 stops above and beyond. So let's say I kind of zeroed in on 60th of a second as my base exposure. It was going lower and higher than that. But I think I want to, with this next Eclipse, be a little bit more sensitive to the shutter speeds, because yes, you definitely risk the chance of getting a sort of a blurry moon with that as well. During the corona, we'll want to overexpose quite a bit, and that's something I saw a lot of. The more we overexpose, the more we can get the detail, and yes, we'll blow out the actual center of the eclipse, but we'll get a longer and longer corona, because the corona is just, that's sort of the shot that everyone dreams about when we're in totality. And you'd be surprised how long that corona
really extends.
It's almost the size of 1.5 other suns.
Right.
Past that. I don't know, Rebecca, you might know this specifically, but it's always there. We just never see it because
maybe we'll get like a lucky solar ejecta at the same time.
Yeah, get some auroras coming our way, right?
Gabe, I do want to go back to one thing that you mentioned, which is important. And that is, you were talking about when setting up a shot and framing it and choosing a focal length. And then you were talking about showing the eclipse in relationship to the environment that you're in. And again, it's this difference between a headshot and an environmental portrait. And again, it gives you a sense of place. And that is a really important thing, because if you're just going to take a shot, this is just my take on it, let's get as close as we can and fill the frame with it. Just go online. There'll be 80 billion pictures just like that, from a variety of locations. But only you can set up a shot that is environmental and is local, that is identifiable, whether you have to travel to this place or whether there is a location near where you live, walkable or drivable, whatever. But to pick out a situation that is recognizable, that tells its own story, and then place that eclipse within that, incorporate it into it.
On that note, Gabe, do you have a favorite image, not necessarily yours, but just out there in history of the solar eclipse?
Well, I mean, obviously I have my favorites, and my favorites tend to be the wide shots. So I will say the diamond ring shot I got in the 2017 definitely trended. This is so interesting because we definitely live in a glory age of capturing the eclipse, right? So I think in 2017, I was one of the first people to get it out there, and I got a diamond ring effect. And by chance, I chose to stop down my aperture significantly. I was at like f16, f22, which I don't think many people do. But again, when we stop down our aperture, we're going to highlight any flare. That's what the diamond ring is, as Rebecca mentioned. It's that flare, right, of the last glimpse of the sun behind the mountains of the moon, right? And the shot that I got of the diamond ring flared like no one else's. That extended. So that trended nicely, and that was quite a unique thing. And we kind of talked about juggling. You're going to juggle a lot of stuff. That's where the practice will come in. You can't practice the diamond ring. You can't practice totality until the moment is here. A friend of mine, Clarence Spencer, used an infrared camera in the 2017 total eclipse, and he got a phenomenal shot. He used an infrared converted camera, which I wouldn't think of using, and he really overexposed his shot in a bracket mode, and then blended them together. I think he said the maximum shutter speed he went was up to 20 seconds. Now, again, that's for the corona. So he really got a very extensive corona. But what was unique about his shot was using that full spectrum converted camera. Part of his overexposure, he got actually detail on the moon in front of the sun. We never see that shot. You always just see the black hole, right?
Full spectrum infrared has color in it.
Full spectrum is full color.
Extends into the infrared.
I was doing a lot of research because I was doing an article on the history of eclipses, and the first photograph of the eclipse, which happened in Egypt, I'm spacing on the photographer's name, but that first photograph, which of course we're talking 1897-ish time frame, also had a comet in it.
Wow.
Right? It's in public domain, but that's a really cool one. And again, we have the opportunity, hopefully, to mimic that shot this year with the comet is. Exactly.
I was wondering what the relationship in the sky is between the comet and the sun. I mean,
it's going to be in that same area, so you can get the eclipse and the comet. We don't know, I think, exactly where it's going to be, but it is going to be in that range. You could probably get it with a telephoto lens if you had that 100 to 400 or 150. You might need to adjust a little bit, but definitely look for it. I will be.
Interesting. Yeah. Something I wanted to bring up, Gabe, and we haven't discussed this at all. Again, trying to be inclusive of all of our listeners, and we're talking about a lot of photographic gear and telephoto and wide angle. A lot of our listeners only have smartphones or plan on using smartphones. How practical are they? What are some tips you might have for people who are going to be trying to get good shots with their smartphones? Any thoughts?
Yeah, sure. That is the way of the world, right? We'll all have one in our pocket as well. So I advise you to use your smartphone multiple ways. Now, shooting the actual eclipse with the smartphone, it's going to be that wide angle shot, right? I mean, because most phones I know only get to maybe 70 or 100 millimeters, so you're really not going to be
somewhere around that.
Don't think of it as that detail oriented one. But here's what I would say is go in video mode, and again, document the environment you're in. That's what I would say. Maybe you can start videoing right before the eclipse. And I've seen several of these as well. Maybe get a gimbal to steady it, but otherwise just have that steady hand and just swipe around, do a little slow, steady pan. And again, capture the environment.
Capture the other people photographing.
Capturing the hoop and hollering that's going on and the other
reflections.
people.
Reflections, and then like again, the coming through the leaves onto the ground. There's a lot of ways of doing it indirectly.
Exactly.
To capture it. Well, that's a very good tip.
Yep. So, I mean, you can use it to maybe get a little bit of the moon. You can definitely get solar filters to put on your cell phone as well. Most of the people that I've seen that have done that don't really, again, they've been doing it more. But again, I believe we carry this moment adapter that you can put over, and then you can put 67 millimeter filters over your iPhone. You can also get the ISO certified material and just tape it over as well if you really want to do it prior to totality. But then during totality, just document. Go to video mode, right?
Yeah. I remember like early on, like I had the very first iPhone and my friend had a telescope. And I remember one of the first uses of the camera, just putting it up to the eyepiece of the telescope and taking a picture of the full moon. I looked at that picture, and this is 2009 or 2007, I think. And I was like, wow, it was really detailed. It was super sharp. It was just a picture of the optics of this like dinky telescope, but the moon was right there on my phone. It was really great. So
yeah, and that's, I mean, again, there'll be a lot of quote unquote star parties out there. And the easiest adapter out there is to adapt a phone to it. And so there perhaps will be opportunities.
One last thing I wanted to touch on. You mentioned earlier you're interested in capturing the quality of the light as the sky darkens, but the moon is up high above the horizon. So it's not coming through the atmosphere like we normally would. That's why sunsets look red. It's coming through all this atmosphere. Here it's coming directly, but the sky is dark. Is that what you're referring to, in this sort of silvery quality light?
Well, that and that it's also, it's diffused, right? Because the moon's in front of it.
Yeah,
right. So I think Rebecca mentioned it, and that is part of the whole experience of the eclipse, is that lighting is unlike
It's very surreal.
anything that
very
we
weird.
ever experienced.
It's not nighttime as we know it.
It's, I mean, you can say twilight, but it's not, because it doesn't
It's
have
not
that
even
blue.
really twilight. Yeah.
It's a metallic twilight, right? You know, so it's silvery. I call it silvery light. And then, of course, hand in hand with that is that the world goes silent, hopefully, right? But insects, birds, animals, wildlife just all of a sudden are like quiet.
And everything starts smelling like damp firecrackers. It's very strange. For those of you who didn't read the book, you won't get it. But it's
Inside joke. Go get the book now.
Yes, please do.
Catch up with us.
So, Gabe and Rebecca, you're both going to be at the Ecliptic Festival. Can you give us an idea what you plan on doing there? I know, Rebecca, you're going to be speaking there. And Gabe, what are you going to be up to? If you could each take a couple of minutes and fill us in on what you plan on doing there.
Yeah, so one of my talks is about the relationship that we have with the moon. And I think, a solar eclipse is about the sun because it's the daytime, the sun is vanishing. It's this kind of bizarre and terrifying event, but it happens because of the moon. So I want to talk about the moon and how it's the central feature of this event and why we should all care about it. And then I also have an event with you guys where I'll be doing a sort of guided stargazing talk and looking through some telescopes about what we can see, because an eclipse happens during new moon. The moon is not up at night, which means it's a really great time to look for deep sky objects and other items that you would not be able to see when the moon is out. And especially where we're going to be, it's a very dark area, so should be really good seeing, hopefully.
Cool.
Yes, exactly. And like you mentioned at the beginning, this will be B&H's second time at the Atlas Obscura Ecliptic Festival. And that's, I think, something to hit upon, that it is a festival, right? There'll be something for everyone.
Yes.
And right, from music.
Blonde redhead.
Exactly, right? And education, inspiration. And B&H is sort of doubling down on the experience, and especially on the educational, hands-on experience. We're going to bring several telescopes with us, as well as we're going to bring several cameras with long lenses and short lenses and set up this shooting area or experiencing area that people will be able to look at the sun during the day. And we'll put solar filters on so you can get a good look at the sun during the day and get ready for the eclipse. And then at night, we are going to turn both the telescopes and our cameras and do a variety of different things. We're really excited. Rebecca will be partnering with you on that experience as well. We have invited a couple other of our personal friends who either do night photography or do astro deep space stuff. And we're working with the owner-director of Rocky Mountain School of Photography. His name is Forrest Chaput, and he studied astrophysics and loves astronomy. He had built his own observatory where he lives in Montana. And so he'll be one of our experts on the telescope side of things and be doing a variety of different things to help you see different things at night and help educate people. He's done a great job of teaching first-timers to experience the telescopes. And ideally, you can come over and experience it and perhaps attach your phone, maybe capture a picture of something, or depending on what adapters and stuff. But in an ideal world, you can either bring your camera or your phone and adapt it to some of those telescopes, or bring a memory card and put it into one of the cameras that are also set up there. Another one of our friends, Susan Magnano, who has worked quite a bit with B&H, to really fully embrace the festival side of things. Yes, exactly.
Light painting.
Well, right. Like, I know it's luminous. She's going to be taking luminous portraits, right? She's called it like graffiti, luminous portraits. We'll make sure it's a little further away from the people that are just wanting to be looking through the telescopes and other.
Keep those groups segregated.
We'll keep them at a safe distance. But she does these amazing portraits of people where she uses these tubes, colors, luminous objects. And so hopefully you can also come to the B&H area and walk away with a portrait of you, your friends, your family from the festival at night. These obviously work best at night. So really excited to be working with her. I'll be there as well to kind of just help with all things above and beyond. If you want to learn anything about night photography side of things, especially, that's my expertise. So whether you want to just take pictures of deep space, my personal favorite, again, is astro landscape, right? Telling the story between the sky and the beautiful things that are going on up there and the landscape and what story is to be told there. And I think at a festival, we'll be in a valley. It's not like we're going to have like a huge mountain in front of us, but I'm thinking about taking pictures of people and of the stage, or just other sort of things that really, again, tell the story of where are you and the story with the sky.
Cool. And podcast engineers were gratis, right? I'm totally comped for this. So I can...
Exactly.
So dope.
Gabe's also going to have a kiosk. He's going to be selling his latest line of hats.
Well, listen, you all know I wear fedoras and hats. I'll be definitely bringing straw hats, because we've talked about looking at the reflections of the eclipse through leaves, through colanders, through pinholes. Well, listen, I'm going to be pulling out a straw hat. You might see Gabe without a hat, or just with an extra hat that he's using to take the pictures of the reflections of the eclipse.
Moonrise over Gabe's head. I already got it linked. Let's do it.
Yeah, I'm there.
Exactly.
Rebecca, I just wrote down some stuff here that I just wanted to get your thoughts on. There's been a renewed interest in all things lunar in the past, like maybe 10 years. Maybe this started with like SpaceX, and then other countries successfully landing on the moon, especially China and India, and then the shows For All Mankind. And then I went finally a couple months ago to the Wikipedia page for the Artemis project, which just is like, I'm still browsing it. It's like the complexity of this mission is just unreal. And then I went to the Wikipedia page of the Starship human landing system, which needs an elevator to get the astronauts to the moon surface. So this is not the lunar landers of yore. So you must be stoked about all this stuff. But I'm curious as to, why do you think there's been, in the last, say, decade or so, this nascent second lunar arms race almost? Can you explain? Because there's not a lot of stuff up there at the moon. Is this maybe like a trial phase run to do asteroid mining, or other? The profit motive and incentives are sort of beguiling to me. And I thought maybe you might have some opinions about that.
I have a lot of opinions.
Yeah.
I think there's a lot of reasons why people are interested in the moon right now. And I think one of them is that, for the first time, countries other than the US are going up there and have successful space programs. You mentioned China and India. Japan just became the 5th country to land an object on the moon just last month. And now private companies also have their eyes on moon riches or moon development of some kind, moon mining maybe. And I think some of that stuff is pretty far afield. I think probably further afield than some of the stockholders of these companies would like to admit. But I do think it's in the future, and I think it's more possible now than ever, in part because of this sort of renewed geopolitical motivations. It's not quite the Cold War that we had in the 60s that drove Apollo, but it also, isn't not that. With respect to China, especially, like China is very keen on putting its taikonauts on the moon, and
Taikonauts?
U.S. taikonauts are the word for Chinese astronauts.
Dig it.
And like the Russians
Right.
are called cosmonauts,
Sure.
and we all have kind of our own little lingo.
Taikonaut.
But yeah, they're very interested in being up there, and I think the NASA administrator and American politicians have been very clear that we want to be the first ones to go back, and we don't want China to get there next. We want to get there next ourselves.
People.
And have our own new milestones. Yes,
Right.
with humans.
Right.
With human crews. But China is very active up there. They have another mission coming up later this year. That's another sample return mission. India has a successful program. They've landed a couple times.
We landed one sort of upside down, I think, yesterday or the day before, right?
Yeah.
Well, we
this new
slid into
commercial
third
lander.
base. That's
Okay,
how we're
okay.
determining,
That's probably the right analogy. Yeah, it's kind of on its sideways,
who's either that or be out,
Right.
Yeah, that's right. Better than getting tagged out.
Or falling back to Earth like Gene Roddenberry's ashes. Yeah.
Yeah. This was the first commercial lander to make it up there, which is actually a really big deal. I mean, this is not a government-sponsored probe. This was built by a private company, publicly traded company.
Taxpayer funded.
But they do have NASA funding for sure. They have NASA grants, and NASA put some instruments on this thing. But it's not like it was during Apollo, where it's like this is a NASA spacecraft. This is a private company's spacecraft, and NASA is hitching a ride. And that's a really new paradigm for the moon. Not for space. I mean, this is what we've been doing the last 15 to 20 years now in space, is this kind of commercial industry around getting to low Earth orbit. And that you mentioned SpaceX really is the main driver of a lot of that. But also NASA gives SpaceX a lot of money.
Right.
And SpaceX's successes have sort of rested on the shoulders of NASA grants trying to foster this whole economy where it's not just NASA sending people and rockets up there. It's companies that NASA is paying to do that. But then that means anybody else can pay them to do it too. So that's going to really change our whole experience of the moon, I think, in the next few years.
Yeah, exciting times.
If anybody wants to catch up on the realities of space travel, and we're talking about mining and taking advantage of the moon and asteroids and all that stuff, I'd recommend taking a look at another book called A City on Mars, which Rebecca actually reviewed for Scientific American, I believe you said.
Yes.
And it talks about the realities of what is involved in all of these things we're talking about doing, with like harvesting this and settling there. The hard, true realities. And it makes you realize that climate change is a piece of cake compared to living on the moon. It really, really is. It's actually, I think we'll want to focus our energies back on that. But again, if you're really interested in that, I would say that two books, the one we discussed today, Our Moon by Rebecca Boyle, and this other book called A City on Mars, answers a lot of questions and brings up a lot of new questions. And it just gives you tremendous amounts of food for thought. But as I mentioned up earlier to Rebecca early on in the show, this book is more than just about the moon and facts about the moon. It talks about how the moon affects the most basic parts of life, how our cultures have evolved, how everything has evolved on this planet Earth based on our relationship to the moon. Tremendously researched and very, very well written.
Thanks.
And I highly recommend this book to anybody who's had interest into this big gray ball that sits above our heads that we've all been staring at for the millennium.
Rebecca, I really appreciated the little sort of footnote factoids. Especially the real mind-blowing one was the I'm not sure what it's called, when the planets lined up, 1079 BC perhaps, and China sort of, it influenced their dynastic regime
Yes.
change.
The mandate from heaven.
Mandate
Yeah.
from heaven.
Yeah.
It sort of describes the dynastic revolutions henceforward until today. 3,000 years ago. It influences the physical evolution of humanity and also, I guess, our cultural evolution as well.
Yes.
Well, the sky was our internet back then, right?
Yeah.
Seriously, that was our entertainment, was the sky, the dark sky, and the day. So.
Hey, what's on in the heavens tonight, dear?
What's on the heavens tonight, Uh-oh.
Yeah.
Oh, man. Well, Rebecca, Boyle, Gabe, Biderman, it's been terrific speaking with you guys today. Rebecca, aside from the festival coming up in the Eclipse, what else do you have coming up on your agenda? Anything going on that we'd be interested in?
I'm going to the Tucson Festival of Books in March, which will be my first book festival as an author. So that'll be fun.
That's cool.
And then, I have a couple events in libraries and different places in the country that I'm either doing in person or Zooming into them. And you can hear me on a lot of podcasts. I've been doing it.
Have you been booked or is there any discussion on getting on Sean Carroll's podcast?
No, that's a good idea, though.
Oh, man. Try it. Go for it.
Yeah, I should have my
Get your
publicist
people
reach out.
talking to that guy. He's the best. I love him. Mindscape, it's called.
And Gabe, what about yourself? What do you got coming up?
So I'm going with B&H. We go to a WPPI, which is a wedding portrait trade show. So we'll be out there for that. But then I leave immediately for that to chase another wonderful celestial fascination. That's auroras. And I'll be going to Norway, up to the Lofoten area up there. I'll bring in a small group up for that experience. And then after that, I go right from that pretty much to the Eclipse. So I've got a nice full plate. But I will say, I'm also with my group National Parks at Night hosting a really nice in-person, if you're interested in night photography, we do host an in-person event called Nightscaper Conference, the Nightscaper Photo Conference, in fact. We usually have about 300, 400 people come, but it's like-minded people with interest in astro landscape, astro deep space, all sorts of things. There's star parties to go to as well. But that's going to be September 26th to 29th in Kanab, Utah. So if you can't make it to the Ecliptic, which we all hope you can make it to the Ecliptic Festival, just to experience that. Another good thing to do would be the Nightscaper Photo Conference.
Sounds cool. Sounds good. And Gabe, it's always great having you on the show. This is not your first visit here. Seriously,
good to be back.
You always have great input and great energy, and it's always nice hearing your voice. What can I say?
Thank you. You as well, buddy.
Great. That's great. And Rebecca, it's been a pleasure having you on the show. Again, your book is called Our Moon, How Earth's Celestial Companion Transformed the Planet, Guided Evolution, and Made Us Who We Are. It's a tremendous read. It'll give you an enormous amount of food for thought. It'll pose questions to you that you never thought of, and you'll want to know the answers. And she gives them to you, which is really kind of wonderful. So again, thank you both for joining us today.
Thanks so much for having me. This was fun.
Thank you.
Great stuff. If you're a fan of the show, but not yet a subscriber, head on over to Apple Podcasts, Spotify, or wherever you get your podcasts and click subscribe. You can also find this on the Explorer blog, where we post photos from our guests along with our show notes. And please join us on Facebook at the B&H Photography Podcast Group, where you can share your favorite photos and comments about the show. I'm your host, Alan Weitz. Jill Waterman is our creative producer. Episodes are recorded, mixed, and edited by technical producer Mike Weinstein. Our executive producer is Bjorn Peterson, and our editorial director is Sean Steiner. On behalf of all of us, thank you oh so much for tuning in today.
Thanks to Panasonic for sponsoring this week's episode.